Hello, everybody. It is Mr. Zentner here with the read assignment for week 7. We were talking about sources of climate change and some of the theories that go along why climate change is happening. So it's a shorter reading. There's two small articles and then some questions in the usual setting. So let's begin. Intro. Over the years, there have been many suggestions as to why the climate is changing. Some people suggest that the climate changes naturally from changes in the sun, like how we had ice ages. Others have said that volcanoes are responsible for all the carbon dioxide in the atmosphere. These articles below investigate those ideas. Let's find out what the real cause of climate change is. This first article is Do Changes in the Sun Cause Climate Change? And it is by NASA. It's from NASA. We know changes in Earth's orbit around the sun are responsible for the comings and goings of the past ice ages. But the warming we've seen over the past few decades is too rapid to be linked to changes in the Earth's orbit, and too large to be caused by solar activity. The sun doesn't always shine at the same level of brightness. It brightens and dims slightly, taking 11 years to complete one solar cycle. During each cycle, the sun undergoes various changes in its activity and appearance. Levels of solar radiation go up and down. So does the amount of material that the sun sends into space and the size and number of sunspots and solar flares. You can click on that link if you want a little bit more information about sunspots and solar flares. It's pretty interesting stuff. So, what effect do solar cycles have on the Earth's climate? The current scientific consensus is that long and short-term changes in the solar activity play only a very small role in the Earth's climate. Warming from increased levels of human production of greenhouse gases is actually many times stronger than the effects of solar activity. For more than 40 years, satellites have observed the sun's energy output, which has gone up and down by less than 0.1% during that period. Since 1750, the warming driven by greenhouse gases coming from humans burning fossil fuels is over 50 times greater than the slight extra warming coming from the sun itself over the same time interval. So that's saying that even though we've seen a little bit of difference from the sun's energy, greenhouse gas warming is 50 times more significant. If we look at this graph here, we can see the comparison between the two. The red is the temperature, and the yellow is the sun's irradiance, which is the energy coming from the sun. Okay, let's move on to the next article. The first 4 questions down here are about that first article, so go answer those. Pause the video and do it. All right, next article, let's start that. Do the Earth's volcanoes emit more CO2 than human activities? This is from USGS, which is the United States Geological Society. Carbon dioxide, also known as CO2, is a greenhouse gas and is the primary gas blamed for climate change. While sulfur dioxide released in volcanic eruptions has occasionally caused detectable global cooling of the atmosphere, the carbon dioxide released in volcanic eruptions has never caused noticeable global warming in the atmosphere. In 2018, human activities were responsible for 35 billion metric tons, also known as gigatons, of CO2 emissions. All studies to date of global volcanic carbon dioxide emissions show that present-day volcanoes release less than 1% of the carbon dioxide released currently by human activities. Scientific estimates of global CO2 emissions rate for all eruptions on land and underwater lie in the range of 0.13 gigatons and 0.44 gigatons per year. The 35 gigaton projected human-produced CO2 emissions for 2018 is about 80 to 270 times larger than the maximum annual global volcanic CO2 emission estimate. There is no question that a very large volcanic eruptions can send significant amounts of carbon dioxide into the atmosphere. In 1980, eruption in Mount St. Helens blasted approximately 10 million tons of CO2 in the atmosphere in 9 hours. However, it currently takes humanity only 2.5 hours to put out the same amount. So while large explosives like this are rare, but they can occur